This is question number 15th of IOQM 2024 and 25. And the question over here says, let X be the set consisting of 20 positive integers, that is n, n plus 2, and so on till n plus 38. The smallest value of n for which the any three numbers a, b, c, not necessarily distinct, forms the sides of an acute angle triangle. So if these are forming the sides of an acute angle triangle, the basic condition over here will be that any one angle, the cos theta, has to be positive. Now we can start from this point. Now the first one is that we know that if a triangle is possible, then the sum of the two sides has to be greater than the third side. Now in this case, if we need the minimum value over here, then in that case we need to take a and b has to be minimum. So we can write over here that this n plus n has to be greater than c. So c is the largest side, so we can take this is n plus 38. So from here, from first condition, we can see that n should be greater than 38. Now moreover, this is the value of n for which the triangle will be possible. Now the second thing, if we need to consider that it's an acute angle triangle, then we need to apply a cosine formula. Then we can see the cos of the longest side, that cos of c is going to be equal to a square plus b square minus c square divided by 2 times of ab. Now this quantity has to be greater than 0. So this simply implies that a square plus b square has to be greater than c square. Now in this case, a is the smallest one, so this is n square plus n square, and this should be greater than n plus 38 whole square. So if I've been solving this, I'll be getting this equation as n square minus 78n minus 38 square. This has to be greater than 0. So from here, if I'm going to calculate the value of n, so this n will come out to be greater than somewhat 91.74. So if n is coming out to be greater than 91.74, so the value of n that we have to assume with the help of this and this has to be equal to 92, and therefore this should be the final answer of this question.